Hello everyone. This video would focus on determining whether or not a given equation is a direct variation or not. Before we go further, please feel free to check out the description below for the link of the other series of topics related to direct variation. To better understand what a direct variation is, let's have a review on the definition and real-life examples of direct variation. We remember that, by definition, direct variation is a type of proportionality wherein one quantity directly varies with respect to a change in another quantity. To better understand this, let's look at variable A and variable B. For a direct variation, if variable A increases, variable B will also increase. Now, please notice the direction of the arrow. Both of them are increasing. On the other hand, if variable A decreases, then variable B would also decrease. Again, please notice the direction of the arrow. Both of them are going down. Again, please notice that for a direct variation, both variables have to increase or both variables have to decrease. So whenever we see this type of relationship where both variables increase or decrease, we can go ahead and say that A varies directly as B, or we can also state this as A varies proportionally as B, or A is directly proportional to B. Now let's take a look at some real-life examples of direct variation. Okay, the number of hours you work and the amount on your paycheck are directly proportional to each other, which means that if you work more hours, then it means that you get more money. On the other hand, if you work less hour, then it means that you get less on your paycheck. So again, the number of hours you work is directly proportional to the amount of your paycheck. Now let's take another example. The speed of a car and the distance traveled in a certain amount of time are directly proportional to each other, which means that if a car travels faster, then it can travel more distance. It can cover more distance at a given certain time. On the other hand, if a car travels slower speed, then it can cover less distance. This tells us that the speed of a car is directly proportional to the distance it traveled at a certain amount of time. Okay, going back here, we remember that the general equation of a direct variation is y equals kx, where our k is the proportionality constant, while our variable y is the dependent variable, while the x is the independent variable. So we can tell that a given equation is a direct variation if it comes to this form. Now let's go over some examples. Okay, looking at this example right here, we are supposed again to determine whether or not the given equation is a direct variation or not. Again, the general equation is y equals kx. If you notice, we can tell that this is an example of a direct variation. It's because this resembles that of the general equation of direct variation, y equals kx. So I'm just going to go ahead and label that down here. Okay, so our k here is -3. So this is an example of a direct variation. Now let's go over the next example. Okay, so we can tell if a given equation is a direct variation or not. We're supposed to isolate y by itself. So y goes with 5. So what are we going to do is we will divide both sides by 5. So we can have y by itself here. So this is over 5. And then we're going to divide both sides again by 5. So we can cross this out. So we are left with y equals 7 over 5x. And so this is the simplified equation of this given equation that we have right there. So we can go ahead and say that this resembles that of y equals kx. So then this is an example of a direct variation with k value of 7 over 5. So I'm going to go ahead and write that down here. Okay, now let's go over the next example. Okay, in this example, we are given y equals 5x minus 2. We remember that the general formula for a direct variation is y equals kx. Now, please notice that we have a y, we have a k, which is 5, and we have an x. However, there's a minus 2 next to the 5x. So then we can go ahead and say that this is not an example of a direct variation because it does not resemble that of y equals kx. There was an extra of negative 2. So we can go ahead and say that this is not a direct variation. Now let's move on to the next example. Okay, again, we remember that we can tell if it's a direct variation or not by setting up y by itself and then figuring it out if it's in the form y equals kx. Since 3 goes with y here, so we're going to go ahead and divide both sides by 3. So I'm going to divide this by 3 so that we can isolate y by itself. So divide each of them by 3. So then we can cross this out. We are left with y equals 1 over 3x minus 2. So that's 1 because remember there's a coefficient of invisible 1 in front of the x. So that is 1 over 3x minus 2. As you can see, this does not resemble that of y equals kx because there was an extra negative 2 at the end. So then we can go ahead and say that this is not an example of a direct variation. So I'm going to go ahead and write that down here. Okay, now let's move on to the next example. Okay, again, in this example, y is not by itself. So we need to isolate y by itself here. So what are we going to do is we will subtract 8x from both sides. So minus 8x and minus 8x so that this would come out. So we can cross the 8x out. So we are left with negative 3y equals negative 8x. We wanted y by itself, so we go ahead and divide both sides by negative 3. Divide this by negative 3 so that we can go ahead and cross out the negative 3 and negative 3. So we are left with just y on the left side. So y equals 8 over 3 x. Now, please notice that it comes out positive because you have a negative divided by a negative is a positive. And so this is the simplified equation for this with y isolated by itself. And please notice that this resembles that of y equals kx. So we can go ahead and say that this is an example of a direct variation with a k value of 8/3. So I'm going to go ahead and write that down here. Now let's move on to the next example. Okay, in this example, again, we're supposed to isolate y by itself. We can do that by dividing both sides with 9, since 9 goes with y, and we wanted y by itself. So I'm going to divide this by 9 as well, so we can cross this out. We are left with negative 1 over 9x equals y, or we can rewrite this as y equals negative 1/9 x. Now, please notice that this resembles that of y equals kx, with our k is negative 1 over 9. So then we can go ahead and say that this is an example of a direct variation with k of negative 1 over 9. So I'm going to go ahead and write it down here. Now let's move on to the next example. In this example, y is not isolated by itself on the left side. So we go ahead and isolate y by itself so that it comes out to have a form of y equals kx. So we go ahead and subtract 4 from both sides, minus 4. So we go ahead and cross out the 4 and negative 4. So we're left with y equals x minus 4. Now, please remember that the coefficient that we have here is an invisible 1. Please notice that this does not resemble that of y equals kx because the negative 4 messed it up. So we can go ahead and say that this is not an example of a direct variation. So I'm going to go ahead and write that down here. Now let's move on to the next example. Again, in this example, y is not isolated by itself. So we go ahead and make sure that y is by itself on one side of the equation. But before we go over the example here, we can see that we have a positive 5 and negative 5. So then this cancels out, it becomes 0. So 5 minus 5 is 0. So then we are left with 3x equals negative 2y. We wanted y by itself, so we can divide both sides by negative 2. Divide this by negative 2, so we can cross the negative 2 out. We're left with y equals 3 over 2. That's a negative x. Or we can go ahead and rewrite this as y equals negative 3 halves x. Now, please notice that this equation, y equals negative 3 halves x, resembles that of y equals kx, which is the general equation of a direct variation. And we can see that our k is negative 3 halves. So we can go ahead and say that this is an example of a direct variation. So I'm going to go ahead and write that down here. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!